Hello friends, my name is Amir and we want to continue free Ccna course, and in this video we want to discuss about what is OSI model. Some persons say Osi model. Yes, and before we start to describe OSI model, we should define what is Tcpip network and what is Unicast, Multicast, and Broadcast. First, Tcpip is a set of standard rules that allow computers to communicate on a network such as internet. It's combination of some rules that help us. Just like people, it's important for computers and for end users to have a common way to communicate with each other. And today, most computers do this through TCP/IP network. And what is unicast, multicast, and broadcast communication? The cast term here signifies some data, maybe a stream of packets also, is being transmitted to a destination from the client side over the communication channel that help them to communicate. Network protocols are like a common language for computers here, and for network protocol we want to know what is unicast, multicast, and broadcast. And unicast communication is from one device on the network transmit data to one another device, only one by one. But in multicast communication is formed that one device transmit data to some devices, to many devices in the network, but not all the devices. But broadcast communication is from one device on the network to all of the devices on the network. And we use broadcast term in networking, I think every time, and we should remember it. And it's a very good idea to learn it. But what is networking protocol? As I said earlier, network protocols are like a common language for computers. Standardized protocols are like a common language that computers can use, similar to how people from different parts of the world, different country may not understand each other's native language, but they can communicate using a shared language like English, like French, like German. Yes. And in networking, protocol is very important set of rules that help us, such as HTTP, IP, TCP, UDP, Ethernet, SSH, FTP, TFTP, or yes, whatever. And some of important protocols that we can define here for you. For example, TCP, Transmission Control Protocol, is defined as a protocol used by the internet to establish a connection between two remotely hosted applications and deliver a reliable data stream from one to other. And about also IP, or Internet Protocol, also is a protocol or set of rules for routing and addressing packets of data. We have learned a little thing about IP in last video, but in next videos also we learn a lot about IP because it's very important for us and it's a fundamental of networking. And we use IP address to establish connection between two devices in networking. And also, what is Hypertext Transfer Protocol, or HTTP, for example, is the foundation of the World Wide Web, or www, and it's used to load the web page using hypertext links. You have seen before when you open a page, you can use www. For example, cisco.com, and in this situation you use HTTP protocol to get information from this website, and this protocol help you to communicate to this website. And what is also Ethernet? Ethernet also is a communications technology that is used to connect devices in a local area network or LAN. In LAN network, also we use Ethernet. But what is OSI model or Osi model? Osi model is a foundation that you learn about networking, how networking works. Networking functions in 7 layers, and in 7 layers you should learn how does, for example, application work, how does presentation work, and session, transport, network, data link layer, and physical. Because when you send any packet from one device to other device, it should transmit from layer 1 to layer 7, or maybe from layer 7 to layer 1. For example, if you want to open a page in networking, which layer you should use in this situation. OSI model describes 7 layers that computer system use to communicate over a network, and is very, very important and fundamental for IT and networking understanding. We should start from layer 7. In layer 7, or application layer, is used by end user. You can see equipment is computer. You can find it in computer. You cannot find it in cable or in intermediate devices like router and switch. In computer. And is used by end user software such as web browser, email clients. For example, you open Outlook, you open your web browser. It provides protocols that allow software to send and receive information and present meaningful data for user. And in this layer, something like HTTP, SSH, FTP, and redirector also works here. And you use browser to get access, for example, and use HTTP to access to other maybe websites or database and something like that. And also maybe some app, web application. And this is application. And you works with data. And about presentation layer, also it works in computer, prepares data for the application layer. It's very important. You want to provide data for application layer, and it defines how two devices should encode, encrypt, and compress data so it received correctly on the other end. It means any computer sent to other computer in this level and in this layer, it should be encrypted. It's not plain text and encoded by 0, 1, for example, the by maybe some key and some services here. And session layer creates communication channels called sessions between devices. If you, for example, open your bank Kanto, any session open for you, and you have maybe limited time to use it. After, for example, 20 minutes, come back and you want to check it again, this session is locked and it's closed. It is responsible for opening sessions, ensuring data remain open and functional while data is being transferred, and closing them when communication ends. It's very important. For example, you use you log in with your username and password for any app or something like that, and any session will be open for you, and it is a duty of session layer. And for example, you can work with SQL, RPC, or XPin or NFS. It works here. And also about presentation, I have also forgotten something like SSL and TLS function in this layer. What is transport layer? Transport layer also is very important. Transport layer takes data transferred in the session layer and breaks it into segments on the transmitting end. It is responsible for reassembling the segments on the receiving end, turning it back into data that can be used by the session layer. Transport layer carries out flow control, sending data at a rate that matches the connection speed of the receiving device. And error also control, checking if data was received incorrectly, and if not, requesting it again, because you send any packet to other devices, but it will be divided in different segments. And after that, destination receive this data should be collected again, and is the duty of transport layer. And you can see we can see any data name here. This is segment data, segment name, and we use TCP and UDP. UDP is not reliable, but TCP is very reliable, but it's not very fast. For example, so some features should use TCP, some should use UDP. For example, if you look at any video in YouTube, you should use UDP, but sometimes it's TCP, because sometimes maybe you interrupt any data here. And what is a network layer? Network layer also, the network layer has two main functions. One is breaking up segments into network packets, and another reassembling the packets on the receiving end. The other is routing packets by discovering the best path across physical network. The network layer uses network addresses, like IP address is very important here. You can see use packets and IP address and IPX, and Apple Talk is the most important protocol here. And also we use IP address to route packets to the destination, and it's very important. We have also data link layer. Data link layer also establishes and terminates a connection between two physical connected nodes on a network. It breaks up packets into frames and sends them from source to destination. This layer is composed of two parts, LLC and MAC. LLC, which identifies network protocol, performs error checking and synchronize frame, and also MAC or media access control, which uses MAC addresses to connect devices and define permission to transmit and receive data. Switch use data link layer, and switch works in layer 2 and works with MAC address. If you send any packets to other device using switch without router, it means you should use MAC address of two devices, and is important in switch operation. But in network layer, unlike data link layer, you use router, and you should use IP address to transmit data, and is a difference between them. And also data material is frame. We have also physical layer. Physical layer is responsible for the physical cable, wireless connection between network. Everything about cable, Wi-Fi, wireless, physical connection is physical layer, and the first layer. And it defines the connector, the electrical cable or wireless technology connecting the devices, and is responsible for transmission of data and works with 0-1 code, computer code, and IT code, as you know. But this is 7 layers of OSI model, but we have also TCP IP model is 4 layers, and application, presentation, and session, you can call them application in TCP IP model. Okay, you can see TCP IP model here, and transport is transport also same, but network named internet in TCP IP model, and data link layer and physical layer also combine in network access. We have 4 layers in TCP IP model, but we use OSI model today, and it's very popular to understand network operation. And network cabling is a layer 1 of OSI model, one of the most important part of network. With the media, the network traffic can travel from one end to the other end device. This can be done through wireless network, like Wi-Fi you call, and but network cabling is always used even if wireless network are used. We have different cable like Ethernet. Also, we have 10 base, 100 base, 1 TX, T4, FX, FX, SM, and different information. For example, Ethernet or 10 base T is provided with copper twisted pair cables, and also types of fast Ethernet that we have here. Also, we have half duplex or full duplex information. Half duplex is a port can send data only when it's not receiving data. In other words, it cannot send and receive data at the same time. You can see only can send here. But in full duplex, all nodes can send and receive on their ports at the same time. And it's different between half duplex and full duplex that we work with it in media. Also, there are 2 standards for Ethernet. This is 802.3i and 802.3x, because one of them works in half duplex and one of them works in full duplex, and is different between them. And we have talk about. We have network cabling. Another form for network cabling, the first one, it was Ethernet cable. and another one, this is fiber optic cable type is. Fiber optic cable, first the basics. Single, we have two form for fiber in networking. In network cabling, fiber has different modes and use any the material to work and transmit data here, and it divides to multi and single mode fiber. As you can see, for example, single mode short for short distance, less than both of them less than 1,000 foot, and you can see highest bandwidth support is in single mode and lower cable cost, but in multi-mode this is higher cable cost and also lower electronic cost, and yes, some information you can also get from internet. The third form of network cabling, this is twisted pair cable categories. These different network cable types has different properties. By the way, we will hear too much category when we talk about cables in networking, but what are these categories? And there are so many categories, like also WAN, also something like that. But now we should talk about twisted pair cable categories. Mainly they differ with the cable number they use, being shield or unshield. This is different between unshield and shield twisted pair cable. You can see in these pictures, because we used foil shield here, but we use a copper conductor here, and you can see we have some cables here also, and there's different twisted pair cable, Cat 3, Cat 4, Cat 5, and different specification about that. How many, for example, what is the distance, and how many meters can be used, and something like that. But also we have twisted pair cable. Excuse me. We have also coaxial cable. Coaxial cable. Coaxial cable is commonly used by cable operators, telephone companies, and internet providers worldwide to convey data, video, and voice communication. And you can see also in this table difference between UTP, SDP, coaxial, and also fiber optic that we discuss about them. For example, bandwidth. What is bandwidth for them, and what is maximum cable segment? This is for 100 meter, and this is for 500 meter. But fiber, you can use it for 100 kilometer. Between cities, you can use fiber optic. Interference rating is poor, better than UDP, but it's better. Coaxial is better than twisted pair, and also very good in fiber system, and UTP is very cheap, but SDP is costly and is more expensive and more expensive. Yes, and also about security, only fiber is very secure, and now we use the long distance fiber. But we have in packet tracer also, we can see three form for cabling, or also in reality cross cover. For example, between two switch or two router and computer, you should use crossover cable. Between switch and router and also switch and computer, you should use a straight through cable, and rollover or console, you should use it to computer with computer, and using console cable computer can establish connection to switch and also router. This is console cable, if you remember from last video. And we have talked about category here, some categories, and what another category is important. This is WAN topologies. There are different WAN topologies: point-to-point, bus, star, ring, or circular, or also mesh or fully. For example, point-to-point topology connects two nodes directly together. I mean this picture, and often the receiving end of one host is connected to sending end of the another end, and vice versa. Bus topology is in a bus topology, all devices attached to the same transmission medium, as you can see also in the picture here. The medium has a physical beginning and end. In a star topology, we have also star topology here. Each node, like file server, workstation, is connected to a central device called a hub. This is hub here. All of the devices connected to hub, and the hub takes a signal that comes from any node and passes it along to all the other nodes in the network. It's like a server. You have any server here, domain server, and all of the devices should connect to server, and server send from, for example, from PC A to PC B, or PC C to PC D, and something like that. And data on a star network passes through the hub, switch, or concentrator, and before continuing to its destination. Also, we have ring. In a ring network, every device has exactly two neighbors for communication purpose. All messages travel through a ring in the same direction. A failure in any cable or device breaks the loop and can take down the entire network, and is very, very bad situation. You can see ring. If anything happen, for example, here between two devices, this network will be down, and is not safe, and is not as available, and is very old topology. And also we have mesh in this topology. Each node is connected to every other node in the networking, and implementing the mesh topology is expensive and difficult. In this type of network, each node may send message to destination through multiple passes, because all of the devices should connect together. For example, here, this computer connect to this one, this computer connect to this one, and 3, and based on your scenario and based on your design, you can use this topology. But some of them, has some benefit, some advantage, and some also disadvantage. Okay, quiz time. We should take a look at some quiz about this lesson. What type communication will send a message to all devices on a local area network? Broadcast communication is a one-to-all communication. If you can remember, Unicast only is between one-by-one communication, one computer send to other computer, only one. In multicast, send from one computer to many end devices, but not all of them. But also, all cast is not a standard term to describe message delivery, and answer is broadcast, because you can see here for all. A web client is sending a request for a web page to a web server. It means you open your computer and write, for example, www.cisco.com. From the perspective of the client, what is the correct order of the protocols that is used to prepare the request for transmission? As you remember, it's about HTTP, TCP, IP, and Ethernet. HTTP governs the way that a web server and client interact. TCP manages individual conversation between web server and client. IP is responsible for delivery, across the best path about route, find the best route to this destination, and also Ethernet that works in layer 2, takes the packet from IP and formats it for transmission. And right answer here, HTTP, TCP, IP, Ethernet. And also you can see here, HTTP for layers 7, TCP for layer 4, transport. This is for presentation. Application. TCP for transport, layer 4, layer 3 IP, and layer 2 Ethernet. What three application layer protocols are part of TCP IP protocol suite? DNS, DHCP, and FTP are all application layer protocols in the TCP IP protocol suite. ARP and PPP are network access layer protocol. It means it works in layer 2 because ARP works with MAC address, and NAT is an internet layer protocol in the TCP IP protocol suite. And it means if we come back to application layer, this is TCP IP model. You can see HTTP, FTP, SSH works here. And also we have FTP works in application, HTTP works in also application. Also we have HTTP also here, but it's not in this picture, but it works also in application. Excuse me, the DNS I have, yes. Also DNS, it's not HTTP, DNS also, because DNS works with, this is a name resolution, works with translate or convert name to IP address and IP address to name, and this is DNS DOT or domain name service. Yes. Refer to the exhibit. The PC is connected to the console port. The PC is connected to console port of the switch. Okay. All the other connections are made through fast Ethernet links. Which types of UTP cables can be used to connect the devices? We have talked about UTP devices here. This is UTP categories. For example, between switch and router, you should use a straight through cable. Between two router, you should use cross over cable. And if you talk about console, you should use roll over here. And the right answer is here. This is roll over because we have talked about console port, and between switch and router we should use straight through and also crossover between two router. Yes, and it is UTP cables. Which method of data transfer allow information to be sent and received in the same time? It's very easy. At the same time, full duplex can get and receive data, send and receive data. Half duplex cannot, only can send or only can receive data, and this is half duplex. And multiplex and simplex, we don't have any about that. Okay, thank you for watching, friends, and please support me, and maybe with like, comment, or with maybe subscribe. Have a nice day, friends.